So in the last video, we talked about the rational root theorem, and instead of memorizing the theorem, we really talked about the logic behind it, which was if you have a polynomial that you cannot factor and you're looking for possible rational zeros or x-intercepts, you want to try to make your best guess at factoring, right? So you want to say, okay, what do I think could have happened? Maybe there were three factors, right? And I had x, x, and x. That's how I got x cubed. And how are the ways I could have multiplied to -6? And you want to pick factors of -6 as your logical guesses, right? So you might do something like this, right? Say, oh, I could have had x minus 3 as a factor, which would have meant x equals 3 as a possible root. And again, you don't really know if this works unless you multiply it out. But this is a logical guess. And so using that process, you had a list of possible rational zeros, which were essentially just factors of -6. So listing them again, right? We had 1, -1, 2, -2, 3, -3, 6, -6. Now, you would not ever tell me that, I don't know, x equals 7 is a possible rational zero, because that would make no sense. X equals 7 would have to come from a factor that said x minus 7. And why would I put x minus 7 in one of these factors? Because that's not going to get me -6. So you want to use your common sense and understand what is and is not possible. So you might be thinking, well, how do I know if one of these possible rational zeros is an actual rational zero? And this is where we want to use synthetic division. Okay. So hopefully you remember this, but this is just going to be a quick review. So let's just start with the number 1. Let's say we think that x equals 1 is a possible root, right? So remember, there's a difference. X minus 1 is the factor, but x equals 1 is the root, okay? So what you do is you put the root that you're testing, which is 1, on the outside of this like box thing. Okay, you guys probably remember this. And then you want to put the coefficients of the original polynomial in order, making sure you leave a space for 0. So if there was no x here, you'd put like a 0, right? I hope you remember that. So what are my coefficients? 1, 7, -9, and -6. And I'm going to change colors. Remember, you bring down the 1. Okay, then you do 1 times 1 is 1. Put it there. You add these together. 7 plus 1 is 8. 1 times 8 is 8. Add those together. That's -1. Multiply 1 times -1, -1, -7. Okay, so this so 1 is not a root because I have a remainder. Okay, so remember that's a remainder of -7. And I would check other ones as well. And this could take honestly like all day, right? I mean, I have a lot of factors to check. I'm certainly not going to make you on a test like check a million factors. That's kind of, I think, a waste of time. Let's try 6. It's possible that none of these work. And the way to really know quickly is to graph it on Desmos. Okay, so I encourage you to graph this on Desmos, and you'll be able to tell right away if I'm wasting my time. I'm going to do just one more just to refresh your memory on synthetic division. Right, so I write all the coefficients. The root is what I'm putting out here. Bring down the 1. 6 times 1 is 6. I add those together, so that's 13. I'm going to multiply 6 times 13, okay? And I'm going to get 78. All right, so you can tell this is not going to work, right? I mean, I could tell right away there's no way that's going to give me 0, so I'm just going to stop, right? So x equals 6 does not work either. And I could do this, you know, kind of all day, but I did actually graph this on Desmos, so just a quick preview. So when I graphed it, I actually found that none of these possible rational roots were actual roots. So that would just mean that this polynomial does not have any of these rational roots that we've guessed. So I hope that helps a little bit. You might be thinking, okay, well then how am I supposed to graph it? At this point, if you had no possible rational zeros that you could find, you could probably just start, okay, you know your y-intercept, and you could just know the end behavior of x cubed, and I would just make a table of a bunch of points, and you could draw a quick sketch. The other thing you could do is use calculus to find local max and mins, and put those points in as well. So the rational root theorem is just one tool to kind of help you reverse engineer how to factor something that isn't factorable using common sense. In the next video, I'm going to compare synthetic division with long division, so you know when to use long division and when to use synthetic division. And maybe I'll do another example where you actually do have a root and what happens. Okay, so stay tuned for the next video.